The definition of absolute value involves distance that a number is from C. So by agreement, the distance can never be negative. So the absolute value of x equals -5 and the absolute value of x plus 7 equals -15 have no solutions because they're equal to that negative number. However, you have to be careful because something like this equation, 7 minus the absolute value of x minus 5 is equal to -22, will have solutions even though it is equal to a negative number. So let's see why and why we have to be careful. We can't just make any assumptions. So we have had lots of practice solving equations, and with absolute value equations, we will follow all of the rules, treat absolute value equations like any other equation, and follow procedures from solving equations until we arrive at one of the following forms. We want the absolute value of x minus c equals d, or the absolute value of ax minus b equals d. Basically, you always want to have your absolute value isolated. So remember that the absolute value equation of the form absolute value of x minus c is equal to d, and of course where d is greater than or equal to 0, has those two solutions where c is at the center and you're moving a d distance right or left. So here, let's look at this equation. We have solve for x and graph the solutions on a number line. So 3 plus 2 times the absolute value of x minus 2 is equal to 17. So first we need to get it into one of these forms. So let's subtract 3 from both sides. So that is where the 14 is coming from. And then let's divide both sides by 2. That's where the 7 is coming from. And we then have the form the absolute value of x minus 2 is equal to 7. That gives us the absolute value of x minus c equals d. So we can then graphically look that we have a center of 2 and we have a distance of 7 from the left or to the right, making our solutions -5 and 9. Remember, you can also split at that form into two equations and solve algebraically, where x minus 2 equals 7 and x minus 2 equals -7. If we add 2 to both sides, we have our solution of x equals 9. And if we add 2 to both sides, we have our solution of x equals -5. Here's another example. We have solve for x and graph the solutions on a number line for 8 minus 3 times the absolute value of x minus 5 is equal to 2. So we need to get one of those forms. So first we're going to subtract 8 from both sides, which is where they're getting -6. And then divide by -3, which is where they're getting 2. Then you have the absolute value of x minus 5 is equal to 2, which gives you a center of 5 and a distance of 2 to the right or left. You can also solve it algebraically, where x minus 5 equals 2. And if you add 5 to both sides, you get your solution of 7. And then x minus 5 is equal to -2, where we add 5 to both sides and we get our solution of 3. Here's another exercise or another example where we have 19 minus 4 times the absolute value of 2x minus 6 is equal to 3. So first we need to get our form. So we're going to subtract 19 from both sides. That's where they're getting -16. And divide both sides by -4. That's where they're getting the absolute value of 2x minus 6 is equal to 4. That gives the form the absolute value of ax minus b equals d. So let's now use the definition of absolute value so we can see and use this split that it would create two equations where 2x minus 6 equals -4 or 2x minus 6 equals +4. So then you have to solve each equation. You're adding 6 to both sides, and then you're dividing by 2, and you get x equals 1 or x equals 5. You also can think of rewriting 2x minus 6 with that factor of 2. it would be the absolute value of 2 times x minus 3. But then we know the absolute value of a product is the absolute value, the product of their absolute values of the factors. So then that's where they're getting 2 times the absolute value of x minus 3. And then you can use 3 as your center with 2 to the left and the right. Either way, you have solutions of 1 and 5. So here, for example D, we have solve for x and graph the solutions for 6 minus 4 times the absolute value of 6 minus 3x equals negative 18. So first, let's go step by step. We're going to subtract 6 from both sides. So negative 4 absolute value of 6 minus 3x is equal to negative 24. Then we'll divide both sides by negative 4 so that we have the absolute value of 6 minus 3x is equal to 6. This gives us the form, the absolute value of ax plus b is equal to d. So here we can now split algebraically into 2 different equations. Now that we know we have the form, let's see it with the example where we split to 6 minus 3x is equal to 6. But then we also have that 6 minus 3x is equal to negative 6. Then we solve for x. We subtract 6 from both sides. And we divide by negative 3. So our first solution will be x equals 0. Our second solution, if we do the same steps, we subtract 6 from both sides. And we divide by negative 3, will be 4. So graphically on the number line, we're showing solutions of 0 and 4. Now you also could have looked at the absolute value of 6 minus 3x and taken out that factor of negative 3 to have negative 2 plus x. And then we could have rewritten it as the absolute value of negative 3 times the absolute value. And we can even switch this to be x minus 2, more familiar of a format. So that it would be 3 times the absolute value of x minus 2 equal to, it was originally equal to 6. Then if we divide both sides by 3, we have the absolute value of x minus 2 is equal to 2. So we have a center of 2 with a distance of 2, which matches with our graph, giving us solutions of 0 and 4. That's the main idea, no matter how you get there, that we have those 2 solutions.